Now let's move on to the third model available for determining the mass flow rate of smoke out of an opening. This model, like the last one, requires that CE, the coefficient of entrainment for the room of fire origin, and P, the perimeter of the fire, are input, and it also involves the variable kappa. The value of kappa is derived using this formula shown here. It's usually taken as having the value 2. In this model, the coefficient of discharge CD is varied slightly differently than in the other two models. So far, we have only used the values of 0.6 or 1 for this variable, but this model uses three possible values, 0.65, 0.8 and 1. The model is used in the following way. An initial approximate assessment is made of MO, the amount of smoke that's leaving the opening, and this is calculated using the value of 0.65 for CD. Then an approximate assessment of the depth of the smoke at the opening is made using this equation, still with CD being equal to 0.65. A comparison is then made between the depth of the downstand at the opening and the depth of smoke predicted by this simplified formula. If the depth of the downstand is equal to or less than 0.25 of the predicted depth of the smoke, then the value of 1 is assigned to CD. If the depth of the downstand is equal or greater than 2 times the predicted depth of the smoke, then the value of 0.65 is assigned to CD. And if the depth of the downstand lies between these values, that's 0.25 and 2 times the depth of the smoke, then CD is assigned the intermediate value of 0.8. When a final figure has been arrived at for CD, a final value for the mass flow rate of smoke out of the opening can be calculated. Now David's going to do some examples with you in looking at these various models.